So, today's neat stuff is on dictionaries and maps. Let me put it this way. Other than binary search trees and the things that I've done, when I learned this 20 years ago, changed how I thought of how to do programming. Dictionaries and maps is number 2. Meaning, I don't use arrays all that often because dictionaries or maps are called maps in C++. Frankly, line up with a lot of stuff that I do. They act like an array, are easy to work with, and here's a key ingredient to all of this. Remember me talking about the complete class profile where you have your toString taken care of, you have your equals to taken care of, you have all of your other things that you have taken care of, less than, greater than, all that taken care of. Using maps is significantly easier than a lot of things that you might design for a project. That's how easy it is to work with, and it makes more sense, and I'll show you why here in a minute. Okay? So this is an invaluable data structure. Invaluable. What it works with is associative arrays. Now the associative arrays are going to have a tuple of 2 values. I don't want to say it that way. They're going to have a tuple of a key and a value set together. They need both. Now, there's only one key that we're going to use, period. But the value portion can be whatever the heck you want. And that's the beautiful part. Now, for today only, honestly, I'm not going to be talking much, which I'm sure all of you are going to be happy about. Because you're going to be programming a lot. Today, we're only dipping our toe into it just a little bit. And that's about it. Wednesday starts getting uglier. You dip the whole foot in. And then by Friday, you're going to be drowning in it. Okay? And here's why. Is that when you guys go online, you do your normal cheating and stuff like that, all the examples that you see online are using a tuple set that's a basic data type, like a string and an integer. An integer and an integer. I'll be honest, in a lot of stuff that I have, the key may be a simple data type, but the value is a heck of a lot bigger than that, and it's more complex. So, while they show you the baby steps of how to get it running in the examples that you see online, that's great. But how does it work when you need your value to be a little bit more complex than a simple integer? It never happens that way. It's always going to be some type of complex object that you create. And that's what we'll get to by Friday. So today, baby steps, dip your toe in, don't get hurt, you're in the kiddie pool. By Friday, I throw you on the deep end. Okay? Just like this, yesterday, trying to get this fixed. It didn't work. So, how does this work out? When we're using keys, I need you to think of it as an index number. And remember, our index numbers in C++ and many other languages start at index 0. Then increment by 1, go to 1, and 2, and 3. You guys have used that before hundreds of times in arrays, vectors, whatever. Okay? Here, the key is immutable, which is also good, because again, we can think of it that way. Is the data in arrays of the index 1, 2, 3, you can't change that. You cannot use duplicate key values, which also makes sense. You did that in arrays. You can have 2 index zeros. Okay. The neat part about it is you get to design what the key is. The key could still be a number. It could still be a number if you wanted to. But it also can be a string, or it can be even more complex than that. That's the beautiful part about this. Now, so here's the thought. Which one of these makes a sense? Sounds like Italian, so okay, must be the name. As a list, if you're just using an array, we would have to have index 0, 1, and 2 just to place in values for, looks like California, Texas, and New York. So here's the problem, is that I'm not from here, as you know. The number one state that is in my heart is where I'm from. That's Maryland. The number one state that is in your heart, if you're from here, is probably going to be Texas. And I respect, but also respect both. Here's the deal. We have to figure out, if we're using this as a list, we have to figure out what index 0 is. Is it Texas, or is it Maryland, or is it something completely different? We don't know. If we used a dictionary, or specifically a map, again in C++, we can set the keys to make sense. So index 0 makes no sense at all, but if we made it index California, then you would know exactly who that data is related to. The next one, Texas. You know exactly who it's related to. You get to physically change the index number into something that makes more sense for your application. That's the beauty of using maps. Now, why am I using these things? If your project needs to use something like a vector to store data, but your index numbers, well, index numbers just don't make sense, this is why you use a map. Easy reason for why. Here's the funny part. I do some Java programming in Minecraft. And wow. Number one, it's been a long time since I've been called a nerd by a kid. Number two, I really don't remember. No, I get called nerd a lot from my friends, so no, it's not that. But anyway, I haven't failed a student for calling me nerd in quite a while. So. Anyway, so in that revelation, yeah, I can't tell you if anybody's ever played Minecraft before. There's just nothing numbers based unless you have, it's a number of items that you have. You can collect stone, wood pieces, not jewelry, redstone, all these different things that don't make sense if you put them as an index number. So you can do a mapping of, what's one I call it? Coal. Coal you can mine for in Minecraft. So your key would be coal, and then how much you have is your value part. That makes more sense. So mapping just in general works out better. By the way, there's an update hopefully coming soon. But anyway, not like I knew that. So understanding dictionaries through an example. So here's what I'm getting at. Is that honestly a lot of the simple code, again, all I'm doing is getting your foot into the water, or toe into the water, that's it. So what you have on this next page is that you're going to draw out what the map looks like. So again, on the next page, just wait. You're going to draw what the map looks like. And then you're going to make it, you're also going to draw it out. Once the code is complete, what does the map look like? I'm doing some removals. I'm doing some insertions. You're going to draw it all out. I'm not asking you to be Picassos. At least it'll look something like that. So don't make it super pretty. Don't make it super ugly either. Okay? So that's part one. I want you to just do that for the next couple minutes. That's it. Do it as a group. That's all I want you doing for right now is number one and number two. Get to work. And again, your stuff is on the next page after that in your notes. I'm going to leave this here, but in your notes, I want you to go to the next page, draw it out. Scrap paper's fine. I'm not collecting this, but I gotta have you visually understand what's going on here. If you can't get that, we're really screwed with mapping. So draw it out. Alright, let me see your, actually, you know what, I don't want to see your faces, don't take out faces on your screens at your tables. So I only drew one, because frankly I'm being lazy, I'm like, let's go. That's what I should see. Now, I need to see the arrow from Cecil to Elton, because it is by, I don't want to say by reference, but basically it's by reference. So you're going to be connecting to a node-based system just like a linked list. All of you remember linked lists. Put that way, right? So this is by reference. So there is going to be a link. It is a pointer to a linked list at the end. It looks very simple. Okay. Now, I know some of you started this already, but I asked you to wait. Now comes the coding. Hang on a second. Oops, too far. So in the coding, all I want you to do is to get the thing running. I'm giving you the link to download the code. I ran it again last night. Everything should be fine. Copy, paste, get it into a project, voila. But answer the questions that are after it. And that is, when it displayed the map, what did it look like? Were there any surprises? Add the code, and I'm going to put ... You can do the rest. That's what I want you working on for the next probably 15 minutes or so. But that, again, is another learning thing for you guys to have. So I'm going to do that right now for you. I would do it in at least groups of 2, just to make sure that you got it. You can both do it at the same time, but help each other out if something comes up. Just going to do that right now. So when I did this exercise, I was a little surprised by something. Here's why. It's because, like I said, a lot of things that I've done with mapping lately has been either using Java or Python. It's not been using C++. So the interesting thing about this is really, let's see, number 3 and 4. When you displayed the map, there was something very, very, not peculiar with it, but maybe something you're like, damn, I didn't expect that. What was it? There's something obvious. The data was fine, it compiled fine, but when it displayed, there was something peculiar about the display. What was it?
It didn't line up.
Sorry, what?
If they didn't line up,
Yeah.
the elements
Didn't line up?
Yeah, the elements weren't. That's just the spacing was different.
Okay, that I wasn't expecting. So, okay. Yeah.
They didn't print in the order that they were added.
Yeah. Notice the order it was displayed. It was not the order that you put it in, was it? Matter of fact, if I'm not mistaken, you can double check me, the keys were in order alphabetically. Did you put it in alphabetically in the code? No. Now, heads up on this. Python does not do this. Matter of fact, if I remember my Python, it's been not too long, every time you display it, it actually comes up with a different set. It comes up with different, it's still the same keys, still the same data, but the order is completely different each time that you run it. If you ran this again, run it one more time for me, just for giggles. Run it again, compile it, run it again. I bet it'll still display exactly the same order again. I was not expecting that. Now here's the bad news. That takes time. But it depends. It depends on how you do it. Do you want to order your keys after they're all in or before?
During.
Or during. The answer is right. You want to do it during. Now, this opens up another avenue. How do they order their keys? Do they use a binary search tree? Do they use, what data structure is great for sorting? There's a couple of them that we've gone through. Okay. Keeps might be another decent one. Okay. But there's a lot of neat things on how this is done in C++ compared to maybe some other ones. Now, for us, and those of us that are working on projects and debugging things, this is nice to have compared to Python. Okay? So just a heads up on that, because that's a nice little feature to have. Yes, it costs us some time, because it is organizing as we're placing our value in. Okay. Any other questions on what you had in front of you? Yes, sir.
Yeah, is there a feature similar to map that does not order in this language?
They're unsorted set, or unordered set, yes. So I can make that into basically a mapping. So yes, there's a way of unordering. All right, next part. All right, so there's the,
On the part of the code when you do insert, there's a pair.
yeah, it's a great question. He's asking about the pair. It is a key command or one that lights up. So remember that a mapping it needs at least two values. That's what's saying, hey, you're gonna pair these two values, split them up, and then put them as your key and your value. That's what it's basically doing for you. Okay. But yeah, it's a unique word for mapping, let's put it that way. All right, ooh, too far. Okay. Adding complicated structures to value. Now, here's where you're starting it. We did the toe dip. Now we're going to start the ankle dip. Here's what I want with this one, and what you see in front of you. You know what? I want you to draw it out. What am I doing in that code? It's not hard. There's not many lines there. There's no tricks. There's no tricks, I swear. What am I doing? Draw it out. And then I'll draw it out, let's see if we match. Work as a group, there's nothing meant to be confusing. Yes, it is a little bit more interesting, but that's it. So, look at it, draw it out, and go from there. You all right?
Yeah.
There was one spot when I did this originally that oopsed me, and I was fine after that. And that's actually this first line of instantiating our map. It's not this one, it's this one. We all know that the mapping is not going to be, that's really not too difficult to draw out. It's going to have an integer first as our key value, and then it's going to have a vector. I'm going to put dot, 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 so we don't know how long that vector is going to be. That's nice, by the way. That's pretty nice and powerful to be able to use our STLs that we already have before into the same thing. It's beautiful. But again, the more complicated that I start getting, the more things I got to make sure that I'm covered. The overloaded less than sign, the overloaded C out, the overloaded this and that, and everything else that we talked about before, in order to really have it work for our benefit. So, what I have here next, let me see. Is this line right here. I'm hoping everybody sees it on their screen. Alright, so in my map, I'm inserting, just like we did before, I'm inserting a pair, which is our vector and our int and our int vector of 10, and then the vector int. Does anybody remember what 10 was? What is 10? 10 is the key, and then what is associated to that key is the vector behind it. Everybody okay with that? So in reality, it's going to look like this. 10 is our key, and right now our vector is not there, but it's a vector. So now you'll see the next two lines. It says my map of 10. I think it's a pushback. Is it pushback? Yeah, pushback, and then I add a value. So when everything is said and done after those couple of lines, I can go ahead and have this. Dot, dot, dot. It's at 10. So my first one is 1. The second one is 2. Everybody okay with that? Any questions on that? All right. Then we have our iterator for loop. to go through a vector just like we did with vectors. That code did not come from God. That code came from us using vectors. Okay? It was literally copy and paste from my notes from vectors. Are we okay with that? Any questions? Now, what do I got? 13 minutes left?
Yes.
Okay. Here's what I want you to start on. The only thing I want you to do today, as a group, is draw out your game plan for this. Here's what I want you to do. It's right underneath as a code. Is that I want you to create a stem and leaf mapping for temperatures in steps of 10. Starting at 0. You're going to use the chart of high values that I have underneath. For right now, for the next 10 minutes, all I want you and your group to do is basically come up with a game plan on how this is going to work. Here's what I need you everybody to do real quick. Google, go to Google. I forgot a link in there, it's my bad. So go to Google, type in stem and leaf, because I'm not guaranteed that all of you know what it is. That's okay. That's why I meant to have a link in there. And I'll tell you what link to click on real quick. It is the first one that shows up. It says www.mathisfun.com data stem leaf plots. Click on that. Listen carefully to what I'm asking for. I don't want you coding this. The only thing I want you to do is to draw out the game plan. You can also use the data for the last 2 weeks to kind of show how it should look. But you're going to use this mapping to map our high temperatures for the last 2 weeks. How are you going to do it? Show me with the drawing. I do not want code yet. I will give you code time on Wednesday. So I got 10 minutes.